We're now going to discuss Chapter 4 of the California Plumbing Code, which is plumbing fixtures and fixture fittings. To reiterate, again, the California Plumbing Code has been defaulting to material manufacturers' installation instructions. So project inspectors need to have copies of the installation instructions so that they can verify that the particular installations of systems, components, and elements complies with the manufacturer's installation instructions. And let me just take a second here to remind everyone that the numbers in parentheses off to the end of each bulleted item actually identifies the section in the chapter where this requirement is identified. Another important concept is that backflow prevention is provided per ASME A112.18.1/CSA B125.1. That's very important, and we'll talk much more about backflow prevention later in this presentation. Accessible plumbing facilities are required to be installed per the applicable building regulations, which are Section 403 and specifically dealing with school construction and essential services buildings, which is DSA work, the California Building Code, Chapter 11B. Exposed pipes, supply and drain, under accessible lavies and sinks are protected against contact. Now, this is something that's been in effect forever, as long as I can remember. It's been in Chapter 11B of the CBC forever, and it is very important that the California Plumbing Code is also in agreement with the accessibility individuals and designers that anything that's underneath a lavy or a sink is protected against contact. So this includes hot water, cold water, the valves, and the P-trap. In the old days, it used to only consider what your knee could actually touch if it was rolling up under a counter that had a sink or a lavy on it, primarily hot water and sharp edges. So now this generally takes care of anything that you would come in contact with underneath a lavy or a sink. They've got to be protected against contact. Beginning in the 2016 edition of the California Plumbing Code, the Division of the State Architect, as well as other state agencies, launched an aggressive attempt to conserve water in the state of California. As part of that attempt, significant water conserving fixtures were identified and in fact required for installation subsequent to that date. The 2019 edition has continued those water conserving efforts, including additional requirements for some other systems. The main changes that have occurred are primarily just numbering changes. The actual quantities and the conservation efforts that have been launched have remained the same, and there have been no dramatic changes. However, the importance is this information needs to be provided on the submittals. So when a project inspector is reviewing submittals for any water using fixtures, whether it's metering faucets, shower heads, water closets, urinals, lavies, sinks, any type of water use fixture, you need to make sure that the flow characteristics for each of the fixtures complies with the code. And here's a continued list of some of these water conservation efforts. You've got wash fountains, metering faucets, lavies, sink faucets, kitchen faucets, and some of the things to consider are Some of these calculations are based on gallons per minute, and some of the calculations are based on gallons per flush or per cycle. So it's important to understand those distinctions and review those during your reviews of materials that are submitted for use on these projects that use water. There are situations where schools have got gymnasiums and locker rooms. Particularly in high schools, we may see the use of bathtubs and whirlpool bathtubs. In these situations, we've identified these four main characteristics just because they are sometimes seen, they are rare, but the 1.5-inch minimum waste outlet and tailpiece is required, which must obviously include an approved stopper or a strainer. I mean, that's very similar to any bathtub, whether it's a whirlpool or not. An overflow has got to be installed, and again, that's required per section 404.1. The maximum temperature of the tempered water coming into the tub is 120 degrees Fahrenheit max, and that's consistent throughout the code for any water that a person is going to use for personal hygiene purposes. 120 degrees Fahrenheit is the max hot water temperature. The water supply has also got to be protected by an air gap or per section 417, and obviously that's because we don't want cross-contamination. Nothing has really changed, nothing new there, but it is important because of its uniqueness. Speaking of uniqueness, non-water urinals is an interesting topic. Several years ago, I believe in another effort to attempt to conserve water, non-water urinals became somewhat popular and began to be installed in some areas. Problems were identified just shortly after the installation of these particular units, primarily from a hygiene standpoint. However, and when I say hygiene, I mean sometimes there was an odor that was detectable with non-water urinals. After several years now of seeing these in use, another deficiency has been identified, and that is the fact that these particular drain outlets from non-water urinals tended to create sediment in a higher concentration than in piping where water is generally flushed through the piping. So where non-water urinals are installed, it's required now that not less than one supplied fixture, rated at not less than one water supply fixture unit, is installed upstream of the line. And what this does is this actually makes sure that water is flowing out of the outlet of the non-water urinal. Now obviously that doesn't include the piping coming directly from the non-water urinal to the branch line, but it does help to mitigate some of the buildup of sediment. It was determined that water is needed to clean the waistline from the non-water urinals that are in the horizontal position. And again, this keeps down on this sediment matter, which is called struvite. Okay, struvite is a mixture of various chemicals, including magnesium, ammonium, and phosphate. And it collects very quickly and solidifies in the drain piping leading away from the urinal. Unfortunately, this image depicts a picture of a waistline that was removed from behind a non-water urinal, and you can see that it's been reduced from whatever that is, 2-inch, down to maybe 1/2-inch capacity. And the other chunks that are shown underneath are a variety of different pieces of varying concentrations of struvite that have been taken from piping. Okay, this is simply an image showing what non-water urinals may look like. These are two typical designs that are installed just for informational purposes. Okay, section 416.0 addresses emergency eye wash and shower equipment. The image to the right shows a typical installation of an emergency shower and eye wash station. And there are a few things that are specific to these emergency devices that we want to remain completely aware of. Number one, water supply flow rates are not limited. And I think the reason is obvious. You want to make sure that you can deluge someone that has accidentally spilled some sort of toxic or corrosive or poisonous substance on their body. You want to make sure you can flush that off as quickly and thoroughly as possible. These have got to be accessible for immediate use. Obviously, if someone in a wheelchair had an accident, we cannot deny them the opportunity to flush those toxic chemicals off their body, so it's got to be accessible. The path of travel has got to be unobstructed. This particular device has got to be identified with signage. And most interestingly, a drain is not required in these areas. I think that's most interesting because you would expect that any time that you're anticipating dumping possibly several hundred gallons of water onto the ground, that you would have a way to readily take that away. Well, drains are not required. However, the thing to remember is if a drain is required, it makes this a very special drain system from this perspective. If you're washing off chemicals, those chemicals are not permitted to be included or introduced into the standard sanitary sewage system. Those chemicals can be very hazardous and very dangerous and destructive to the sanitary sewer system, either at the building or further down range at the septic treatment system. So these particular, if you saw a drain at a emergency shower unit, that drain system would have to comply with very specific requirements with respect to materials use and also keeping those chemicals in that drain system and venting system completely separate from the sanitary sewer system. Section 418 talks about floor drains, and an important thing to remember about floor drains is, even though it doesn't seem apparent, floor drains are considered plumbing fixtures. Okay, they must comply with ASME A112.3.1, ASME A112.6.3, or CSA B79, and there are very specific requirements for floor drains with respect to outlet sizes, inlet sizes, strainer volumes, etc. As I said before, these are considered plumbing fixtures. They require an approved type strainer. Because these are fixtures, they must be trapped, and we discuss traps in section 10. Floor drains must be installed in toilet rooms, commercial kitchens, laundry rooms, boiler rooms. An indirect waste piping is required at food storage areas. Generally what we'll see is indirect piping into something that looks like a floor sink. You've got an air gap or an air break that's required depending on the design parameters. And of course, floors are required to slope to the drains. And all of this is going to be very clearly detailed in the approved plans.